All right, guys. Thank you for joining the call. Uh, let me open the whiteboard first. All right. Do you guys recall what did we discuss in our last session? Yeah.
Hello.
Hmm.
I think last time we discussed Fortigate architecture, hardware acceleration, and SPU, NP, CP, etc.
Correct. So we discussed hardware acceleration. We also discussed security processing units. Let me grab my headphone now. Please confirm if you can still hear me. Hello.
Yes.
Yes, bro.
In the security processing units, we discussed network processor, and we also discussed content processor. And then we said that the content processor is basically used for content inspection, right? It is sort of a UTM thing, right? And the network processor is used for networking purpose. Yeah, and it is a routing thing, right? We also try to discuss what are the major differences between VM and hardware. So, a couple of questions on that one. So, you can always sort of do trade-off between when you should go ahead with buying a hardware and when you should actually go ahead with buying a VM. So, it will always depend on your requirements, right? And the one critical point that we noticed last time was that this guy would never support the hardware acceleration. And what's the reason for that? Anyone? Hello? Can you guys still hear me?
Yes.
Okay. So, do you want to answer this? I can only see SB here. Okay, Samit. So, yeah, why do we say that the VMs won't support the hardware acceleration? It's a very important question, and also from the design point of view or the sales point of view, you might have this in future or whenever you're sort of doing the implementation. Okay, similar concept that the VM is actually nothing but a virtual machine, right? It's like a 40
Yeah.
OS firmware or 40 OS program or software, right? Running on some different host. right? So this is going to act as guest operating system, and then it runs on maybe a bare metal, or it could also run on uh, something that's also running on your machine. For example, you can run this on VMware. VMware itself runs on the Windows, right? So considering that, it always would rely on the host operating system for the resources. Uh, and when we say resources, we talk about the CPU, memory. So since it's itself a virtual machine only, it's only a program only, right? A software only. So there is no hardware. So you cannot inbuild or incorporate any of the other hardware modules here into this VM and then say that I want to accelerate it with the help of that. So BIOS tweakings might not. Do you want to explain that? What does BIOS tweaking basically mean? Maybe for the other people.
तो जो मेन ऑपरेटिंग सिस्टम होगा वो चेंजेस उसमें आएंगी,
Mm-hmm.
क्योंकि ये विद इन ऑपरेटिंग सिस्टम एज जो वीएम है, तो वो तो ऑपरेटिंग सिस्टम के बाद अलग से मशीन एक चल रही है, तो मे बी वो, तो जैसे हम रैम जैसे ओवरक्लॉक करते हैं, तो
Mm-hmm.
माइट वही कॉन्सेप्ट इसमें ना लगता हो, क्योंकि ये अलग से बूट होता है वीएम।
Mm-hmm.
तो वही मैं बता रहा हूँ, लाइक प्रोसेसर को हम कुछ ओवरक्लॉक करें या कुछ, तो वैसे हार्डवेयर एक्सेलरेशन का भी ऑप्शन शायद बायोस में ही आता होगा, तो उस वजह से।
Okay.
Maybe I'm
Are you
not
talking
correct.
from the resource point of view that you cannot
Ye-
increase the
yes, yes,
resources of?
करेक्ट, क्योंकि
Okay, and
इसमें वो एसवीएम एनेबल करना पड़ता है ना, अगर हमें वीएम चलाना पड़े, उसके बगैर तो ओपन ओपन ही नहीं होता है ये, तो मुझे
you
लगा
might
शायद
not be
वैसे।
able to open it, but you can still increase the resources, right? It's also important to mention. So there is always an option. So I guess Aaron might be able to explain that better. So if this is your, for example, the ESXi, right? ESXi is nothing but a bare metal server,
व्हाट इज अ
right?
बेयर मेटल एक्चुअली?
Uh, it's a hardware basically, right? It's a hardware. And what you do is you sort of run a virtual, you call that hypervisor, right? Hypervisor is nothing that is actually going to help you with translating the calls from one operating system to the other operating system. Now, let's say, for example, this was a Linux based bare metal server. I have got it from Dell. Dell basically sells this stuff, right? Now I'm running hypervisor on top of it, and then I have uh, FortiOS running over here, right? Now, this guy will always be dependent on ESXi for its resources. And when we say resources, it will be CPU and the memory. Now let's assume that this particular guy itself comes with the 16 CPUs and 1 TB of RAM. 1 TB of RAM. Okay, 1 TB of RAM. And maybe I have 1 TB hard disk as well. Right. Just for the heck of it, I'm just trying to make the numbers so that it can fit the example. So you can always say that I want to give 4 CPUs here, and then at some point when you say that, okay, the CPUs are getting exhausted, now you can always come back and say that, okay, hey man, since it's being managed by this ESXi only, you can always come to the ESXi, say that, and say now that, okay, instead of 4, I can give it 6, or instead of 6, I can give it 12, right? But you can never exceed 16, right? Because the host itself has only 16 CPU. So from the resource point of view, it's always scalable, and that's actually the whole point of having VMs. Even when you talk about the clouds, for example, let's assume that this was not running on the on-premises ESXi, right? Or maybe a vendor, you have basically sort of taken this ESXi on rent from from a vendor. Now, what you do is you can also run this Fortigate VM in the cloud, right? There is a concept of Fortigate VMs, right? You run them in the clouds, and when you say cloud, it's basically the Fortinet cloud, right? Fortinet actually helps with managing all that infrastructure and all, so you don't have to take care of the maintenance and the rest of the stuff. So you just have to use it. You just try to access it directly uh, from your office by redirecting every traffic to this particular node, right? So that can be one of the cases. And at that time also, you can always do the resource resizing. Resource resizing. So from this particular point of view, I mean, there is no dependency. I mean, you can always come back and say that I need to increase the RAM. I need to increase the CPU now, right? So I don't know if you actually mean BIOS tweaking from that point of view, but if it's about uh, the resources, right, you can always tweak it. Any further question? Does that answer your question, by the way? Fazan, you're on
यस
mute.
यस यस
Okay.
ये तो वही बात हुई ना कि हम अगर रिसोर्सेज को completely like 100% यूटिलाइज ना कर पाए कम पड़ रहा तो हम उसको like ड्यूअल बूट ही कर लेते हैं फिर ताकि तब जाके
Mhm.
वो अच्छे से कम्युनिकेट कर पाए जो हमारी like कंपोनेंट्स है प्रोसेसर वगैरह सब कुछ
Mhm.
तो वो मैं बता रहा था लाइक हमारे पास कोई लो एंड पीसी है तो
Okay.
वीएम शायद उसमें लैग करे तो फॉर एग्जांपल जैसे लिनक्स तो वो तो लाइट वेट ऑपरेटिंग सिस्टम है बट स्टिल विंडोज उसकी मेमोरी इतनी ले पाता था कि इसके लिए कुछ नहीं बचता था तो उस केस में हम डायरेक्टली अलग सा ऑपरेटिंग सिस्टम ही इंस्टॉल करें इसमें ताकि विंडोज बूट ना हो डायरेक्ट लिनक्स ही बूट हो तो मे बी शायद फिर जो हार्डवेयर एक्सेलरेशन है शायद वो वैसे चल पाए
Mhm. So I'll try to explain this one more time, what I actually mean by hardware acceleration. See, the whole point of hardware acceleration was that if this was an independent box, right, it is not dependent on anything for the resources which are constrained always, CPU, right, and storage, right? You call this memory, right, and you call this, it could be hard disk or it could be SSD, whatever it is, right? So every calculation was taken care by the CPU only first, and then you said that, okay, what I can do is I can tell CPU that you just take care of the first packet, maybe like sin, right? And then drop it to somebody else. And I am basically putting this somebody else from outside. It's again an independent box. It has a microcontroller of its own, by the way. Yeah. And it's also able to do the calculations, right? So this particular box is called ASIC, Application Specific Integrated Circuit, and it's actually there to help your CPU to reduce the load on it, right? And the only reason why I was not able to, I'm just trying to keep it simple now to not get into the more BIOS details and the double boot thing because other people might not be able to relate it. So for the VM, since it's just a firmware, right? It's a program running on the or dependent on the other hardware. You know what I mean? So I'm running this particular firmware, which is nothing but the 40 OS, and it's able to run because of a host operating system, which is built on some different hardware, right? So all the ASICs are not present in here in this particular hardware, so you cannot basically come and support the CPU over here. That is the that is actually the only point here, right? And by some chance, if you just say that I still want to incorporate the hardware acceleration over here, you can sort of do the tweaking, but that tweaking will only be for this particular main operating system that you were just discussing, right? It can only be done for this particular operating system and not to the exact one, because this has no hardware on of its own. It's dependent on this hardware, and for that reason, if you want to sort of do some optimizations or resource resizing, or you want to say that okay, there is some virtualization you want to bring in, right? You can sort of play with this only, right? So that is the whole point of hardware acceleration. Okay.
Hello.
Yes.
Nasir, sometimes like we host two operating systems on a single machine. Will that work on that time? For example, I'm having a laptop, let's say
Mhm.
Lenovo laptop I'm having, and I have hosted Windows operating system, Windows 11 as well, and I have hosted a Linux machine on this side by
Mhm.
side. I can switch the operating systems not by any virtual machine tool, like for example VMware, etc. I'm hosting both the operating system on the firmware. Will the hardware acceleration work on that time or not? Because on that time the operating system is having the physical access, physical machine access, physical resources or physical hardware access.
Okay, let's talk about, so what is the machine? Is it Lenovo?
Let's say Lenovo machine is with
Okay, so Lenovo has the operating system, right? And what is the operating system? Windows.
Windows, yeah, and
And
let's say Kali Linux.
Kali Linux. Kali Linux.
okay, so both of these can act as host operating system. You can maybe boot via Windows, you can boot via Linux. Is that what you mean?
Correct. Yeah.
And what is the other part of the question?
Can we like enable hardware acceleration on that time or not on any machine like Windows or Kali Linux?
Hardware acceleration from which point of view? Do you want to tweak the host operating system at that time only? See, if this is utilizing the resources from this one only, this is also utilizing the resources from this one only, right? The hardware that is actually present on your machine only, right? At that time, the tweaking again happens on the hardware, right? And by tweaking, it never means hardware acceleration basically. So these are two different things. Let me just try to draw a line between these two. So I could tweak it, I could optimize it, but from hardware acceleration point of view, it is like you have additional hardware to support your current OS, right? So do you want to bring in some different hardware and then sort of support this host operating system?
No.
If that is possible here, I don't think that is possible. So uh, then it becomes hardware acceleration, right? Which actually might not be possible, right?
What do you mean by like hard like BIOS tweaking? Could you please elaborate that a bit?
BIOS tweaking is more of a thing that where you can play with the BIOS settings, right? You can always come and sort of say that I want to uh, increase this particular thing, uh, maybe in terms of the resources or in terms of any of the processes that can actually help your uh, software to maybe process faster or to get optimized in that sense, right? Hardware acceleration is you bring in a new module. It's like an additional module that will offload the CPU of its task,
Okay.
right? A simple analogy again. One guy is just trying to, there's a guy, right? He's really working hard, right? And what you can do to this guy is you can just support him by you just pay him, right? You can pay him money. It should be the one thing. It's sort of monetary support. The second thing is you can buy him a good food, right? The third thing is you can sort of provide him more time, right? So from this particular point of view, this is always tweaking, right? And the other way of supporting this guy is you prepare two more people. Say that if you're sort of pulling the logs from point A to point B, right? What we're going to do is we sort of put in one more checkpoint in between. You just put it to A prime, and from A to A, from A prime to B, we are going to take care of it, right? So having the other guys having the additional hardware, which is actually offloading the main process, right? This is basically the hardware acceleration.
Okay. Thank you so much. I got it.
All right. Okay. Let me come back to the agenda now. Okay, so that is the whole point of what we discussed last time. So let me come back to the lab now. So admin, this is Eve. All right, I might need this later, so I'll keep this here. Now coming to our lab. There were a couple of things that we also discussed last time that when you sort of want to implement or connect or mount the Fortigate in your network, there will always be a guy who is actually going to ship this Fortigate to your company, right? He's going to hand over this box to you, right? The first and foremost thing that you always would do is, what do? You do the initial configuration, isn't it? And how do we do the initial configuration? Do you guys recall? How do we do that? Yeah. So we discussed last time that here's the thing. So if this is Fortigate, there is always MGMT port for the high-end models, right? Or if it's not a high-end model, it could be the port one itself, right? This has a capability of acting as a DHCP server, right? And when I say it's acting as DHCP server, so what I'm going to do is I will, if this is port one, I call it P1 or MGMT, one and the same thing, right? I'm going to connect it with my PC, right? And the adapter of this particular PC is going to get an IP address for the reason that this port one itself is an inbuilt DHCP server, right? And what is the IP address that it's actually going to help you with or give you in that range? Yeah. All right. So it's always going to assign the IP address in 192.168.1.0/24, right? And port one itself has an IP address of 192.168.1.99/24, right? And now this is also acting as the DHCP server. It's going to assign an IP address here on this particular PC, and then you can open your browser, you can open your Chrome, and you can type HTTP 192.168.1.99, and there you go. From there, you can just start configuring it, right? We saw this last time, and we are going to see this again today. How you can basically start the configuration, the initial configuration of the Fortigate from the scratch. Let me come here. Okay, let me remove this one lab. So if you check this one, add Epic Pen. All right. So please focus on my cursor. I'm not able to point this with the help of Epic Pen. Okay, some process is going on here. So what I have done here is I have this FortiGate over here, right? This is the FortiGate over here. So this is the port 1 and this is the same port that I'm actually talking about. You can have this named as management or you can have this named as port 1, right? It has a capability of acting as a DHCP server. It can assign an IP address to anything that is connected to you. So in the production, when you're going to connect it for the first time, you'll always have to connect it to the PC, right? This is your PC, and then make sure that this adapter is also acting as DHCP client, right?
Yeah.
And then it's going to assign you an IP address into the range 192.168.1 dot. Let's say that it's assigning you an IP address 1.100, right? And then open your browser, you can access 192.168.1.99. This is the first time you will be opening the GUI of this firewall. Now, what is in my case? That's important now, right? How I have brought it here is I got this and I'm connecting it to the management cloud. This is my management cloud, right? It's the management cloud of this EU, right? And when I do it, since the point here is notepad. When I'm doing this, this is the FortiGate. This is the port 1. This is the management cloud, right? And everything is basically EVE-NG. This is really important, guys. I have already explained this in one of the other videos. I'm not sure if everyone has actually gone through that, but yeah, I sort of thought that I should make this part of this period discussion as well, so that you're just on the same page. So uh, port 1 is acting as DHCP server for anything that you're going to connect it with. That was one of the cases for production. But not just this, port 1 itself also is acting as a DHCP client, right? So my management cloud, which is this MGMT cloud, it is actually nothing but the part of EU. It's one of the adapters in EU, right? My EU itself is hosted on VMware. This is the VMware.
Sorry, why to interrupt you. I have a question.
Yeah, please go ahead.
Yeah. When we are configuring fiber, why
Yeah.
do we need a cloud?
When we are
In the
configuring
beginning,
a firewall.
yeah, I'm saying we are configuring the fiber. We use laptop to configure it. Why do we
Yeah.
need a MGMT cloud like that? Why do we need that?
We don't
Why
need
we are
MGMT cloud at all. We don't.
you
We
just,
need it for
you
the
just-
lab only, right?
Okay, for lab purpose. Okay, got it. Thank you.
Okay. A very good question, by the way. Let me just clear now what I actually want to say here.
Okay.
So let's talk about first the production scenario. Oh man. See what you'll do. In the production, to clear this, clear. Okay. In the production, they're going to give you the firewall over here. Oh man. Okay. Yeah, to make this work, you actually have to be real quick with all these things, and I'm actually not. So if this is port 1, I'm talking about the production scenario. You just connected it with the PC. We just said that this always will have the IP address of 192.168.1.9. You're going to have an IP address in the same subnet for the reason that your adapter is acting as DHCP client, right? So this will be 192.168. I say 1.100, and then you open the browser. You're going to type HTTPS, and then 192.168.1.99, and this will open the GUI of the firewall, right? And when your GUI opens, it's going to ask you for the admin password. We last time discussed that you just put the admin there and then hit enter, right? Then it's going to prompt you to change the password. That's what happens with all whenever you're just trying to log in for the first time in anything. That's what happens, right? So you're going to keep a password. Let's say that I keep the password 1234, right? You repeat the password to confirm it, right? And then you have to do the configuration on this firewall according to your network, right? Because this particular firewall will not be always connected to your PC. The reason you have brought this into your network is because you want to route every traffic of your organization on this firewall and then do the sort of firewall actions, content inspections, right? And then let the traffic go outside, right? So the point here is what I'm going to do is I will do the, oh man, hmm. I'll do the configuration. So in the configuration, there are 4 things which are important. So the first one is I'm going to configure the interfaces, right? And the second thing is I'm going to configure the DNS. The third thing is I'm going to configure the static or dynamic routing, right? And now that you have done this, this is the same stuff that you would always do on a router. And if you get a router in your network, people tell you that, okay, you just have to mount it on the network now. This is what you do, right? You configure the interfaces, you might not have configured DNS on the router generally, right? But you always take care of the interfaces, you always take care of the routing part, right? And now that this is firewall, right? Firewall is a full blown router. This is very important. But the only exception is that it is an idiot device. An idiot for a reason that it's not going to allow anything across. It's not going to allow anything through. So you always would need firewall policies, right? So for that reason, what you're going to do is the moment you configure interfaces, it will be according to the requirement of your network. If you're configuring DNS, it will be according to the requirement of your network. If you're configuring static or dynamic routing, it will be according to the uh, requirements of your network, and likewise the policies, right? So what I am doing here is, now if I come, it is this. Any questions here before I move to our lab part? Because I have to explain why I'm basically connecting that to the management cloud and what is the point, what we are trying to replicate in the lab. Any questions here?
ये फायरवॉल पॉलिसीज का एक बार फिर से बताओ,
Uh,
ये इम्पोर्टेंट क्यों है?
see, Control W. Okay, clear screen. Now let's say that I have configured the, I have configured the interfaces. Damn. I have configured the interfaces, right? Which means that if this is a firewall, this was port 1, Okay, port 2, this was port 1, right? And there is one more port which is called as WAN, right? WAN is actually connecting you to the external internet. So there will be a router here, which you get from the ISP, right? You're going to take traffic that's actually coming to this particular interface, getting to this particular interface, and then it goes to the internet, right? And port 2, let's say that port 2 is acting as LAN, right? And behind the LAN, it's actually connected to a switch. Okay, this is switch, right? And switch has basically the PCs connected, right? So from interface configuration point of view, I'll always make sure that this port 2 is acting as a gateway for all these particular PCs, right? So that whenever they want to go to internet, they sort of have this gateway, they hand over the traffic to port 2, right? And WAN is actually letting you to talk to the ISP router. Therefore, you have to do the static or dynamic routing, making sure that you have a default route pointing towards internet, right? Via the WAN interface, which is the leaving interface, right? And the gateway would be this particular interface, right? Let's say that this is 208.67.220.220, right? Now, if this guy is going to get to the internet, what will happen? The firewall is in between, right? It's a full-blown router, but on top of that, it's doing firewall action. And unless and until you don't tell it that you have to allow these PCs, PC1, PC2, PC3 to facebook.com or internet, it doesn't allow you because it has a one default inherent policy, inherent property, which is called implicit deny. It doesn't allow you unless and until you create policies on top of it. Does that answer your question?
Yes,
Why
yes,
we
I
need
got you
firewall
now.
policies?
Yes.
Okay,
So
shall we
default
proceed?
is there.
Yeah, a default policy is there which denies everything, right? So you will always have to tell it, okay, you have a default policy, but I want to allow this for your traffic. So you create that policy, and that will, when you're going to create that policy, that stays on top of that implicit policy, right? The default policy, so that the traffic gets allowed. We're going to discuss that in detail when we're configuring the firewall policy. For now, the concept is like this. Any further questions till we move forward?
I have a
तो
question.
Hmm.
It might be silly, but I should say it. Why do we install the firewall before the router or after the firewall? After the router. Is my previous organization. I saw that after the router they have implemented the firewall.
There are multiple reasons for this. So from the security point of view,
Mhm.
what you can do is, let me clear the screen. Yeah, so you have a firewall over here, right? What you can do is you can put it behind the router, and then router lets you talk to the um, external world, right? Now here's the thing. This particular firewall stays behind the router. By the way, it's one of the architectures. Let's discuss the architectures, security architectures. Now it's a WAN IP, right? WAN IP means it's public IP, right? And when
Yes,
this
sir.
is exposed to the internet, right? There are security practices that have to be in place, that need to be present in place. You have to buy them from the ISP, right? To make sure that nobody actually compromises this router, because this particular interface is taking part in the internet routing, right? It's letting you talk to the external world. Anything that is on the internet is reachable via this WAN IP. For that reason, this is exposed, so it can be exploited. How? With the help of brute force attacks, right? With the help of DOS attacks, right? Or a lot of things. I mean, you can do DDoS on this as well, right? So there are people who try to compromise your network, right? So they always will try to compromise you. So there is this thing. If you're buying the security, best practice implementations, you say that okay, the ISP vendor who is actually giving me this router, right? If they are taking care of all these things, then this particular architecture makes sense, right? But if you are not buying that for some reason, right, and then you sort of cannot prevent all these things, or even if you do, there'll be a lot of processing that actually goes within the router. So from that point of view, you move to the security architecture second. It's always, I mean, it's not a brute force method that you should do this and not this one, right? It's always dependent on the companies, how their contract is with the ISPs from the security point of view as well, right? And if they don't have any security contract with the companies, they can utilize their firewall to uh, implement all those security best practices. Right now, when I'm talking about the security architecture second, I call this one, I call this second. Here screen. Now let's put the firewall over here. And the router is behind. And then you have the LAN people connected via the switches to this router. These are the switch, by the way. These are PCs connected, right? In this case, your firewall it's an edge firewall. In the recent case, the router was an edge router, right? Now it's edge firewall now. It's visible to the network now, visible to each and everything. This particular WAN terminal is taking part in what? Internet routing now. So who is visible?
Firewall now.
The firewall is visible now. So again, the issues that we have with the router in the earlier case, we have the similar issues here with the firewall as well. But there are firewalls, right? For example, the Palo Alto, the Fortinet, they can help you with reducing the brute force attacks. I mean, I just put it behind. Oh, sorry, I just put it exactly at the perimeter of the network for the reason that if I tried to put router, the router would go through the brute force attack, the DDoS attack, and the ISP to whom this router actually belongs to doesn't provide, or I don't have a valid contract with them, or even if I do the contract, I buy the contract, I will have to pay them, and that's something that I don't want. So that's the reason I would say that okay, let's put the router behind it, put firewall on the front, right? Now, why I'm putting the firewall on front? Because firewall might have something that it's actually able to do that router was not able to, right? The first thing, brute force, you can definitely use your firewall to reduce the brute force attacks, right? There are ways to do that. We're going to see that, by the way. The DDoS, there are modules in this particular firewall which will help you to prevent your network from the DDoS attacks, including this WAN terminal as well, right? So any of the attacks that your router was susceptible, right, and for which you're looking for the valid contract with the ISP to sort of have all those security best practices implemented, you're not able to, you're not ready to do that. So you put the firewall in front and say that, okay, this has a capability of doing it. So why can't I just leverage this one only to help me with all those best security practices which router was not able to? Does that answer your question?
Yes, it is. Thank you.
Now, there's one more question. There are routers which might not be able to help you with the brute force and DDoS. So then there is, now that we're discussing this, let me discuss the last architecture part now. So it's like putting firewall on the perimeter, router on the back foot. The first one was having router uh, on the front foot and firewall on the back foot. Now the final one is I have this firewall. I'm putting the router behind, right? And then I put a DDoS device over here. DDoS module. And then with the help of this, I'm able to get to the internet. So these are for the cases where your firewall doesn't support the DDoS prevention, right? So this is one more security architecture or network design, right? So you are able to get to the internet with the help of this particular interface first, but then you thought that, okay, now that this is getting exposed, it can have issues because it's visible on the public internet. I need modules. Now, does your firewall have modules within? The answer is no. In case you don't have, you have to buy a new one and put that in front, right? Now, the other thing was here. What you can do is you can put the firewall in front on the back foot, right? It doesn't support the DDoS. You put the router in front, right? And your ISPs always would prevent you from the DOS attack. And that's generally the case, right? You might have to pay for them. You might have to pay to them, but ISPs do have the DOS protection enabled, right? They won't let their routers going through the DOS attacks, right? If that had been the case, then you might be hearing the news every other day that one of the firms got DDoS attack on their router, right? That is not the case, right? And that's not the case for the same reason that the ISPs do provide you the DOS protection, right? So yes, we discussed a lot of things today. I've already exhausted 1 hour. Any further questions? We're not even touched the today's agenda, by the way. Questions, guys? Any questions?
Is load balancing something that can protect us from DOS attacks?
Load balancing. I mean, if I just try to look for the literal meaning of load balancers, they will just try to
balance the load.
balance the load, distribute the load, right?
Yeah.
And you might still need to have the DOS protection enabled. I mean, there are load balancers which will help you with these features as well, right? But that is
Load
not the
balancing
actual
on
job
top.
of load balancers, right?
Yeah.
Any further questions, guys? Please feel free to ask. I mean, there is nothing is silly, to be very honest. So everything is actually making sense, and everything is really important. As long as it's just popping in your brain, uh, it has a value, right? And at least for me, I always will keep it open, and I always been the guy who asks dumb questions, and I'm never shy about that. So I would love if you guys shoot the same questions to me, and I won't complain about that ever. And you just have, I mean, that's a promise. So if you have any further questions, or you want maybe say shoot out any questions about anything that we had discussed today, please feel free. The maximum that can happen from my end is that I might not be able to answer, but I do have people here, my colleagues.
So can we discuss about our roadmap?
Definitely, yeah. Uh, let's discuss the roadmap real quick. All right, so go back to the board. Roadmap. The first thing is we're going to do the initial configuration part. Now, initial configuration part would be about the interface configurations, the DNS part, the DHCP part, the administration part, like types of administrators, and there is something called trusted hosts, which is also important, right? And not just this, we are also going to discuss the deployment mode of Fortigate. This is, by the way, the first chapter, right? After that, we are going to discuss the upgrade. How do you upgrade the firewall? For the L1 people, they generally have this use case, right? And what are the precautions or the things that you sort of need to take care of while upgrading the firewall, right? And yeah, one more thing, revision numbers will also be part of the upgrades. Revision numbers. We might discuss link aggregation as well, which is the port channel. So this will be the first chapter, right? The second one will be uh, firewall policies. We're going to discuss firewall policies in very fine detail. The approaches, how a firewall policy column by column actually works. What is the use case of and or operation in the firewall policies. This will help you to understand the identifiers which are actually present in the firewall policy. For example, if Nasir wants to access Facebook, so Facebook itself becomes an identifier. Nasir also becomes one of the identifiers. As long as they're not both valued within the firewall policy doesn't match. And for that reason, it's going to look for that match in a top-down fashion, top-down approach. And if it's, say, for example, 100 policies, and if you're not able to find a match among the 100 policies, you'll always hit the one which is at the below. And which policy is at the below, at the bottom? The
Implicit
implicit
denied.
one, right? And that's how your traffic gets denied, right? So firewall policies would also be one of the things. We're going to discuss the route lookup importance in the firewall policies, right? And then the firewall action comes into picture, right? And then after firewall action, the UTM action comes into the picture. So these are three things, right? And then we are going to discuss NAT. We'll discuss all the cases of NAT, and then there is one important feature which is called central NAT, virtual IPs,
Do we
and
have anything
DNAT.
like U-turn NAT in this Fortigate?
U-turn NAT is, we can do a lab on that. We do have. Yeah, I mean, it doesn't say anywhere there is U-turn NAT specifically, but yeah, we can have a lab on that one. And then we have routing. We're going to discuss all the ins and outs of routing. All right. RPF is something that we'll be discussing here. RPF checks. And then in the routing, I will discuss the SD-WAN. And this is very important, by the way. It's a very basic and very interesting topic. So we're going to pick this up from 0 to 100, making sure that we leave no stone unturned here. And then after this, let me check. We're going to discuss SSL VPN. SSL VPN, a complete discussion of the theory and then the lab, right? The SSL unidirectional tunnels. What's the purpose of these tunnels? Why do we call them the SSL unidirectional tunnels? And how many keys do we actually have in the SSL VPN? We're going to discuss that one. IPsec VPN. We're going to discuss IPsec VPN, a very complicated, actually a very generalized case, which will contain everything, the NAT and everything, and including the theory. By the way, this will be IQV1. If we got time, we're going to discuss IQV2 as well. This is IQV1. I don't know if the lab will allow me to do the IQV2. And IPsec VPN, SSL VPNs. Hold for a second. Let me check what I have in the other module. Okay, the important one, high availability. HA, we are going to discuss in detail. And then we are going to discuss the UTM. UTM will contain your web filter, IPS, SSL deep packet inspection, application control. Might not be able to do labs on all these, but theoretically, we're going to go through all of them, and also from the navigation point of view, right? SSL deep packet inspection. PKI, we're going to discuss its chain of trust.
Yeah.
I'll complete this end to end. I'll make that part of the SSL VPN only. I'm going to discuss that here only. Yeah, that is the roadmap. So let me know if you have any question or you guys feel you want to add anything.
So packet flow will be discussed at last, right? After
Packet flow, we're going to discuss packet flow at last, and there is this concept of slow path, fast path, right?
Yeah. So it will be the
So
last.
they call it, by the way, a very weird name. They call it dirty and may dirty sessions.
The TN made the decision.
Yeah.
We
So
call it
again,
live packet.
yeah. So I mean, it's again the same thing. It's either slow path or fast path.
Well, it has a lot of things, right?
Yeah, we're going to discuss this one as in detail as well. All right, guys. Thank you so much for your time. If you have questions, please go ahead. And we'll have class tomorrow as well, inshallah. We'll try to stick with the agenda to finish that whatever we have. We try to finish that in the same class because today I was thinking of finishing the initial configuration from end to end, but yeah, still quite knowledgeable session. I like the collaboration and having questions. So yeah, keep doing that. If you have any further questions, please go ahead or yeah, feel free to drop.
So is the Udemy still accessible that you provided?
Udemy is still actually